This summer, I worked on 3D microlasers under the supervision of Dr. Lebentel and Ines Perry-Sackley. Microlasers are formed by taking a geometric prism and then illuminating it overhead with light, which due to the geometric properties of the prism radiate specific wavelengths of light or modes. To determine the operating modes of the laser, the resulting comb-like spectrum is captured and a Fourier transform taken. These microlasers have many applications in telecommunications, sensing, and quantum chaos. When working with microlasers, if the thickness of the cavity is on the order of the irradiation wavelength, the cavity is approximated as 2D. Any thickness above this results in the analysis of a 3D cavity. Little is known about 3D cavities, and they are much more complex than 2D cavities. This summer, my work consisted of analyzing the spectrum of a barrel-shaped 3D cavity with the primary goal of determining the operating modes of the cavity and comparing them to a 2D cavity already studied. Our initial thoughts for the barrels were to observe the Fabry-Perot mode and two other possible modes seen in the 2D case. However, no Fabry-Perot mode or any other known expected mode was seen in any barrel tested. After a few calculations, it was determined the barrels were lasing primarily in the Whispering Gallery mode. This is a mode that travels around the perimeter of the barrel. To not observe the Whispering Gallery mode, we tried fabricating used samples that were on posts, had smaller diameter, and eventually with light traps. None of them worked, with the light trap barrels enhancing the Whispering Gallery mode. Current thoughts are that the circular base for the barrels makes them very susceptible to these modes and will overshadow other lasing modes. A new barrel has been designed with a quadrilateral base to eliminate the Whispering Gallery mode possibility. Along with determining the lasing mode of these barrels, I also calculated the ray tracing matrices to determine stability of the Fabry-Perot mode for these barrels and other barrel configurations. Finally, I also designed cavities that will be tested later, such as a strip, Mobius strip, and geometry that has a unique 5-bounce orbit. Experimentation of these cavities, mainly Mobius strip and bounce geometry, expect to show interesting and unique lasing modes. I would like to thank Dr. Lebentel for assistance and support, and the University of Michigan and the NSF for this program.